Hey everyone, welcome back to the channel Code with AKJ. Today is day 35 of solving Geeks for Geeks problem of the day. Today's question is reverse words. So the question says given a string str, reverse the string without reversing its individual words. Words are separated by dots and the note here would be the last character has not been dot character. So given input here, string, I like this program very much. We need to reverse this string without reversing this individual word. So in this example, after reversing the string, the output here would be much very program this like I. Here you can observe that individual words are not being reversed and we need to ensure that these dots should be placed at its correct position. So today we are tackling a simple yet common string manipulation program, reversing a string without reversing its individual words. So the words in this problem are separated by dots, and let's break this problem down and starting from a brute force approach and moving towards the optimal solution. So here the problem gives us a string where words are separated by dots and we need to reverse the order of the words without reversing the individual words. So the brute force approach here would be to split the string into individual words using dot as a delimiter, and we'll store all these words in the form of array, and we'll reverse the order of the words in the array using reverse inbuilt function, or we can use a for loop, and finally join the words back together with dots to form the reverse string. So let me explain through this example. So here the given string is I like this program very much. Initially in our brute force approach, what we'll do is to split this particular string into individual words using dot as a delimiter, and we'll store all these words in the form of array where each and every word would be stored as an individual element in the array, whereas dot would be act as a delimiter. So the array elements would be something like this program and very much. So in this way we'll store each and every individual word in the form of array, and finally we'll reverse this array, and the reversed form would be something like this where it will start with much, very, program, this, like, and I. So after storing it in array and reversing the array, we'll again join these each and every element of this array in the form of string, and we'll place dot after each and every word. So here we'll iterate over this array and we'll take each and every element. Here initially it would be much, and then we'll put a dot after it, and again we'll take another element very, and we'll put dot in front of it, and same goes on with program dot this dot like dot I. And here we need to ensure that the dot should not be placed at the final word. So in this way we can tackle this problem using an external data structure array, and we'll use this array just to store the individual words. And since the problem said that individual words should not be reversed, so with the help of this array and reversing this array, we'll get our expected output. So in this approach, the time complexity would be O of n as we are iterating over the string, and space complexity would be O of n as we are using array as a external auxiliary space. So let's move on to the code. So this is a code for the brute force approach we have discussed through this example. Here I have taken a vector of string of words, and I have converted this string into string stream. So here basically string stream is a class in C++ that allows you to treat a string like an input or output stream, so like scene and cout. So this generally allows you to extract parts of the string using stream operations and making it easier to manipulate this string. So what it does is, since it is a single string, what this function will do is that it will make it as a streamline operation. So it will take each and every character as a stream, and it will calculate and convert this whole string as a stream. And again, after converting it into a stream, we'll use the help of getLine function to generally take each and every stream as a single character. So here the purpose of getLine function would be to read input from a stream until a specific delimiter is encountered. So by default, the delimiter for the getLine function is a new line, but here since our delimiter would be a dot function, hence I have written dot as a delimiter here. So generally here we have used two functions which are present in C++, one which converts the string into stream and one which reads the stream and takes each and every individual word using a help of a delimiter. Here in our case delimiter would be dot, so I have run a loop through this stream which is stored in SS, and I have taken each and every word from this stream and stored it in the variable word, and here we have used the delimiter dot. So while splitting this string with the help of dot and storing the individual word in the variable word, and parallelly I am pushing this word in our vector words. So generally this step will convert our string into an individual words and will store it in our vector of words. So after finishing our step 1, what we'll do is we'll reverse the order of the words. Here I have iterated from the backside of the array and I have added this words of I into our reversed string. So here until or unless we reach our first index, we'll add dot after each and every word, or if we reach at the first index, we'll neglect this step so that our last word should not contain dot after it. So after finishing this whole loop, we'll get our expected output in our reversed string variable and we'll return this string from our main function. So let's compile and run this. So let's submit. As you can see, this problem got solved successfully. And as we discussed earlier, here the time complexity would be O of n and space complexity would be also O of n. So here while the brute force approach works fine and we can make this solution more space efficient by doing the reversal in place without using an extra space here. So we need to find a way to neglect this extra space of vector, and we can do that by using reversal in place. So here's the plan. First we'll reverse the entire string, then reverse each and every word individually while keeping the dots in place. So what we were doing in brute force is that the dots were removed and we took each and every word from this string and we have reversed that word using our external space vector. But what we can do in our optimal approach would be to make sure that dots are not being touched here, and we'll just remove or manipulate these words individually from this whole string. So this approach would be more optimal as it requires in-place modification and minimal extra space. So what we can do in our optimal approach would be to like iterate over the string from the backwards. We'll maintain a temp string and our answer string. Here what we'll do is we'll iterate from the back and we'll take each and every character of this string. For example, if we iterate from this array backwards, so we'll get H first, then C, then U, then M, and until or unless we'll find dot, we'll store all these characters in our temp variable. If we find dot, we'll stop there and we'll reverse this temp string, and after reversing we'll add this value into our answer string, and after adding the reverse temp value in our answer variable, we'll add a dot to our answer string. So in this way we'll again iterate over this array from backwards. Again our temp variable would become empty after doing this one operation, and we'll get values like y, r, e and v. Again we got a dot value, so we'll stop here. We'll reverse this temp value which becomes vary, and we'll add this vary in our answer string where temp dot would be our answer from the first iteration. We'll add vary and again we'll add dot at the end. Again, after this operation, we'll clear the temp variable, and again we'll continue our process from here. So again here we'll get margorp. We'll reverse this temp variable. We'll store this answer to our temp variable. We'll add dot at the answer variable, and we'll clear our temp variable. So in this way, for every operation, until or unless we'll reach a dot, we'll store the characters in our temp variable. We'll reverse the temp variable. We'll add the answer to our answer variable, and finally we'll clear the temp variable. And finally, to handle the last case, since we'll get from here, since we don't have any dot character to stop, we'll generally take the temp variable here until or unless we'll reach the index 0, and whatever the temp string will store the answer, which would be I here, we'll reverse it and we'll directly add to our string after finishing our for loop. So the last case, which would be our edge case, would be handled after we finish our for loop. And finally, we'll return answer, which would contain our expected output, which would be much vary program this like and I. So here the time complexity would be O of n, and space complexity would be O of 1. In worst case, here the space complexity would be O of length of string, as this answers variable will store the length of our original string. So let's move on to the code and let's see whether it gets submitted or not. So this is a code for the optimal approach we have discussed through this example. Here I have taken the string answer and temp variables, and I have iterated over the string from the backwards, and I have processed until or unless we find a dot character. If we find a dot character, we'll reverse the temp variable, temp string, whatever the characters are being stored inside the temp string, and we'll add temp string into our answer variable. We'll add a dot character inside our answer string, and we'll clear the temp variable. And if not, finally we'll push each and every characters into our temp string. So after finishing it, we'll reach at the last index where we'll get our last variable pqr in this case, and we'll reverse this temp variable, which would be pqr, and finally we'll add this pqr into our answer variable, and we'll return answer from there. So let's compile and run this. So let's submit. As you can see, this problem got submitted successfully. So this approach also has a time complexity of O of n, but it's more space efficient since we are only modifying the string in place. So that's it for today's problem. We explored both a brute force solution and a more optimal approach for reversing words in a string separated by dots. So the optimal solution is more efficient in terms of space, but both approaches run in O of n time. So if you found this video helpful, make sure to like and subscribe for more coding content. Comment below with your thoughts or suggestions for future videos, and thank you for watching, and I'll see you in the next one.